Hi class, how are you today? Well, that's a prime answer. The learning target for today is to be able to write a number in its prime factorization and use the GCF to factor an algebraic expression. So two different things we're going to learn about today. For the scale, you're a 3 if you can write a number in its prime factorization and use the GCF to factor an algebraic expression. You're a 2 if you can write a number in its prime factorization or use the GCF to factor an algebraic expression. So you can do one or the other. You're a 1 if you can find the GCF of two numbers. And you're a 0 if you cannot find the GCF of two numbers. Let's get started. All right, so prime factorization is to bring the number down to only primes. So primes are numbers that can only be divided by 1 and itself. So common primes are 2, 3, 5, 7, 11, 13, 17, 19, 23, so on. So in the prime factorization, we're just going to keep dividing out primes until we get nothing but prime numbers. So on this first one, we have 108. So the easiest prime to always divide by is 2. If it's an even number, you can divide by 2. And 108 divided by 2 is 54. Now this method I'm using is called the tree method. There is another method that I'll go over in a second, but this is the first method that I will be using. This is my favorite method, but the other method I'm going to show is also often used and a pretty good method as well. So 54, still even, so we can divide by 2 again. And then we're going to get 27. Now 27 is not even. So that means we have to divide by another prime number. The next one up from 2 is 3. So let's try 3. 27 divided by 3 is 9. Okay? And then 9 can also be divided by 3. And 9 divided by 3 is 3. And now we have all prime numbers at the ends of our branches here. So that will give us 2. We've got 2's and 3's. So there are 2 2's and there are 3 3's. So the prime factorization is 2 squared times 3 squared. If you wanted to write it out fully, it would be 2 times 2 times 3 times 3 times 3. But oftentimes it's just easier to write it with exponents. Now for this other number, I'm going to use the other method that I mentioned. So the method I just used was the tree method, and now we're going to use what's called the ladder method. So instead of going from top to bottom, we're going to go from bottom to top. So 25, 20, and we're going to start by dividing by 2 because it's even. 2 goes into 2 one time. 2 goes into 5 two times with 1 left over. Now this might be something you may or may not have seen before. It's long division, but the kind of a shortcut way to do it. So 2 goes into 12 6 times. And then 2 goes into 0 0 times. This method is really good for big numbers like this. So it's still an even number, so let's divide by 2 again. 2 goes into 1 0 times, so we don't put anything here. 2 goes into 12 6 times. 2 goes into 6 3 times. And 2 goes into 0 0 times. We go again, it's still even. So divide by 2. 2 goes into 6 3 times. 2 goes into 3 one time with 1 left over. 2 goes into 10 5 times. Now, we can't divide by 2 anymore, so let's try dividing by 3. 3 goes into 3 once. 3 goes into 1 0 times with 1 left over. And 3 goes into 15 5 times. Next, we can divide by 3 again. And one little trick to know if you can divide by 3, you can always just try and see if it works. But if the digits add up to a number that you can divide by 3, it works. So if we see 1 plus 0 plus 5 is 6, and you can divide 6 by 3, and so that means you can divide by 3. You can also just try it and see if it works, but that's kind of a trick, and it's kind of neat. So 3 goes into 1 0 times, doesn't work. 3 goes into 10 3 times with 1 left over, and 3 goes into 15 5 times. All right, so 35 is not divisible by 3, and you can tell that because 3 plus 5 is 8, and that's not divisible by 3. So instead, it ends in a 5. If it ends in a 5 or a 0, you can divide by 5. So let's divide by 5. And this one, many of you just know, 35 divided by 5 is 7. So our prime factorization is all these numbers on the outside. So we have 2 times 2 times 2 times 3 times 3 times 5 times 7. Or with exponents, 2 to the third times 3 squared times 5 times 7. These are technically to the 1, but we don't have to put the 1. So this is our answer, and for the other one, this is our answer. Essentially, depending on the teacher, you could have them want the written out method without exponents, or they might want it with exponents. I'm going to ask for it with exponents unless I say otherwise. I'll usually specify which way I want though. But if I don't specify, I'll want it with exponents. All right, so factoring using GCF. GCF stands for greatest common factor. The greatest common factor is the thing that can divide both terms or both numbers evenly. You're probably familiar with GCF, greatest common factor, and doing it with numbers. And now we're going to do it with full terms. But let's start with the numbers. So what we're going to do is, this is often called the backwards distributive property. And you'll see why in a moment. So what we're going to do is we're going to set up a set of parentheses. And first we have to find the GCF. So if you look at the numbers, we've got 16 and 8. The GCF of 16 and 8, the greatest common factor, a number that can divide both of these out, is 8. You can divide 16 by 8 and you can divide 8 by 8. And then the x's. It may seem difficult at first, but really you're just taking out the most you can out of each term. So there's 2 x's on the first term, and there's 1 x on the second term. So we can take out the most that we can out of both. So that means we can only take out 1 x. So we take out an x. And then we see what's left inside. So we're essentially dividing out 8x. 16 divided by 8 is 2. And x squared divided by x, you could just say that we're taking away an x. So we had 2 x's with x squared, and now we have 1. and then plus 8 divided by 8 is 1, and x divided by x is also 1. Anything divided by itself is 1. Or you could just say you're taking away an x from x, and so there's no x's left. So I can make these parentheses a little bit smaller and just say that. And this is our answer. However, I call it backwards distributive property because if you were to distribute that 8x in, so distribute, 8 times 2 is 16, x times x is x squared. Remember, you need to add the exponents, so each of these have a 1 for an exponent. So 1 plus 1 is 2, but anything multiplied by itself is also squared. And then 8x times 1 is 8x. Anything multiplied by 1 is itself. So when we distribute, bring 8x into everything, that brings us back to what we had. So a good way to figure out if you did this right is to multiply back in. If you can multiply back in and get the same number you started with, then you are correct. However, just a reminder, this is your answer. And the part in the red is just checking your work. So for this next one, we have, let's look at the numbers first. So we have 20 and 15. 20 and 15 can both be divided by 5. We've got x squared and x, so there are 2 x's and 1 x, so we take out an x. And there are 2 y's and 3 y's, y squared and y cubed, so we can take out the smallest amount, so we take out 2 y's, y squared. And then we divide everything out. 20 divided by 5 is 4. X squared divided by x, or you have 2 x's, you take away 1, you're left with 1, so just x. And y squared divided by y squared is just 1. So essentially we had y squareds, and we take away the y squared, so there's none left. So now we have the minus. That minus stays there. Don't forget about it. 15 divided by 5 is 3. We had an x, and we took 1 away, so there's no x's left. And we had 3 y's, and we took 2 away, so there's 1 left. And it might just be easier to have only one parenthesis there and throw the other one on at the end, or you'll have to keep erasing like I am. And so there's your answer. Again, you can multiply these out to check to see if you are correct. So when you multiply here, you'll end up with 5 times 4 is 20, x times x is x squared, and you've got the y squared added on at the end. And then here, 5 times negative 3 is negative 15. X just gets added in because there's no x, and y squared times y is y to the third because you add the exponents, and we say that there's a y, we say that there's a 1 when it's just y by itself for the exponent. Again, remember though, this is your answer. All right, now time for the sponge activity. We've got 4 problems here. For the first 2, write each number in its prime factorization. And please put it in exponent form. So we've got 504 and 450, so write them both in their prime factorizations. And then on 3 and 4, factor each expression using the GCF, just like we just did. So on number 3, we've got 49x squared minus 28x, so factor that using the GCF. And on number 4, we have 6x squared y squared plus 18x squared y. All right, that's it for this lesson. As per usual, please make sure to take notes on the entire lesson, attempt all the sponge problems at the end, take a picture of everything, submit it all to Google Classroom, and have a good night.